Good evening. Theory of Computation, 21 CS 503. Myself, Sharmila, Assistant Professor, Department of Medicine, R.M.D.E. Engineering College. In today's video, what we're going to discuss about NP hard, NP hard, NP complete problem. Focus on this. We are getting a definition across what is a midterm, what is a N, what is a NP, what is a complete form of NP complete and NP hard. We're going to discuss, and then we're going to decide about complexity definition, big O and big theta and big omega. In that big O notation, f of n is big O of g of n. If there is a positive constant, we can write it as c of gn for all n greater than or equal to n0, and big O notation, upper bound of the function. This is a given for f of n and g of gn. We are drawing a big O notation. This is the omega notation. In the omega notation, upper bound function was asymptotic, and omega provides the asymptotic lower bound function. Here the functions are 0 less than or equal to c of gn and less than or equal to f of n for all n greater than or equal to n0. This is a diagram for omega notation. Theta notation, the theta notation for both from the above and below the same function g. So the function is 0 less than or equal to c1 gn of c less than or equal to f of n less than or equal to c2 g of n for all n greater than or equal to n0. This is a diagram for c of 2 gn, f of n, and fc of 1 gn theta notation. That is a theta notation. The class P consists of those problems solved by polynomial. At a polynomial time, if you're able to solve the problem, that is called as class P problem. Then that problem that can be solved using the time is O of n power k for the constant k. N is the size of the input symbol. The key, that is the n, is the size of the input symbol. What is the complexity of remote testing is the Boolean example is given. This is the example for class P problem. It can be solvable at a finite time of 0 of square root of n. What is the observe about this premises? Script uses heavily. In the proven 2002, uses complicated number of theory. So it's a NP hard problem. Next one is not the same as a non-polynomial complexity running time. NP does not stand for the not polynomial. NP stands for non-deterministic polynomial time. The NP means verifiable in polynomial time. Verifiable means if we are somehow given certification for the solution can be verified legitimately polynomial time. So what happens the automata? The problem in the NP is it is decidable by some non-deterministic Turing machine, the polynomial time. Remember that the model we have used for is deterministic Turing machine. In the non-deterministic Turing machine, the deterministic Turing machine, remember the conversion given NFA, N state. How many state does the equivalent DFA have? Worst case is 2 power. And the deterministic version of the polynomial time, non-deterministic time, worst case. So here the NP problem is the graph theory, annoying the pair of problems, starters path algorithm. These are the different example of NP problem, Hamilton cycle problem, and the NP hard. What is the NP hard problem? Is L1 less than or equal to L2. Here the notation means L1 reducible in the polynomial time to L2. Here this will basically means that the test taken to solve N1 is no worse than the polynomial factor away from the time taken to solve. The NP hard, they given example is NP hard problem. They given example L for every L dash. Here the NP example from need to be NP hard, both satisfied NP complete problem. Here the NP complete, that helps when we ask to prove the sum of the other problem in the NP complete. Assume NP complete problem for the given solution. We're going to discuss about that Boolean formula 3CNF. There is an example for NP complete problem. So here in this video, what we have discussed is what is N, what is NP, what is NP problem, and what is NP complete, and what is NP hard problem. Thank you.